So we're going to review for your quiz on sampling distributions and proportions, and this video is primarily for those of you who missed the review in class on quiz day. So what is the difference between sampling bias and sampling variability? If you look in your notes, you should recognize this picture where I show 4 targets. Now some people are like, oh, is that what those are? Yes, those are targets. And the bullseye, let's see if I can get a nice... the bullseye is the center here. So we're trying to hit the target with our samples. But if we tend to be off, then we have a bias. And if we tend to have a lot of scatter, that's variability. So this particular example, we have a high bias, but a low variability. Our points are not very scattered, but they definitely are off from the true mean. All right. On the second one, you can see there's a lot of scatter, but if I were to average these out, I'd be somewhere close to the bullseye. So the bias is low, but the variability is high because of the scatter. This third one has both. High scatter, which is the variability, and they also tend to be off from the target on average, so it has a high bias. This last one is what we're shooting for. It's a low bias because on average it's in the center, and it's a low variability, low scatter. So this is what we love. We'll settle for this one with a low bias, but we don't like either one of these with a high bias. So sampling bias is a tendency to be off on your estimate. Typically you tend to overpredict or you tend to underpredict due to bad design. So for example, if I ask people to their face, do you wash your hands after using the restroom? The answers that I collected would be biased because more people would say yes, even though they really don't because they don't want to be embarrassed. Now, sampling variability is from natural variation. It can never be eliminated. Now, you can try and minimize it by going with larger sample sizes, but it's always going to be there. Mrs. Overman is taking random samples of Cedar Ridge freshmen to determine what percentage of the students had heard of mu alpha theta. The population of freshmen she is estimating has 600 students. The proportion of freshmen who had heard of mu alpha theta is actually 10%, and I'm taking samples of size 150. Also notice that I did do random samples up here, so that is one of the conditions. I didn't list it as an option, but we do need to make sure we check that condition, okay? So that's good. All right, so now what do we know? We know that N is 150 and P is 10%. And so what are some conditions we should check? Well, I can see here, one of these is not the conditions. Number of successes needs to be greater than 10, or greater than or equal to, not less than. So when we calculate it, expected successes, I get 150 times 0.1 is 15. That is greater than 10, so that condition is met. Now I have to check expected number of failures. I also want that to be greater than 10, so D is not a condition, okay? So, we'll get to that in a second. Expected number of failures is N times 1 minus P, so 150 times 0.9 is 135, or you could have just said 150 minus 15 is 135. So the expected number of failures is at least 10, so that condition is met, all right? So conditions A and C are met. The next condition we want is here on F, that less than 10% of the population is sampled. So how do we check that? Well, we know that N is 150, but that's more than 10% of the 600 freshmen. So this condition is not met. So the problem is that more than 10% of the population is sampled. Okay, the goal distribution for Reese's Pieces is 50% orange, 25% brown, and 25% yellow. Mrs. Overman samples a 10.5 ounce bag, which has 51 pieces. What is the probability that less than 15% of the pieces are yellow? So first of all, you might be tempted to use a binomial distribution, but since we're testing for a proportion, which is a 15% here, we really should use our sampling distribution to estimate it. So what we're going to do is we're going to go ahead and first check conditions. You should always be prepared to do that. First of all, here's our information. N is 51, P is 0.25, and I'm trying to find the probability that my sample, which is why I have P hat here, is less than 15% or 0.15. So we're going to assume that Mrs. Overman's sample is random. It doesn't really say so, but if you can reasonably assume it, you can assume it. Assume Mrs. Overman knows how to take a sample, okay? The 10% condition, well, is 51 less than 10% of all Reese's Pieces? Yes, definitely. All right. There are more than 500 Reese's Pieces. All right. Expected number of successes for 51 Reese's Pieces, a quarter should be yellow, so I'm expecting 12.75. This is greater than 10, so my expected successes is fine. And my expected failures is the remainder, which is 38.25, also greater than 10. So all our conditions are met. We can use a normal distribution. Okay, so what is probability? We're going to go first of all and write down our values. So this is on your math chart, which you're allowed to use when taking the AP exam. So you should be able to see all this right here. So the mean is the proportion P, and then there's our standard deviation, which it looks like we need to calculate that. So P is 0.25. Sigma of P hat, which is the standard deviation for the sampling distribution, is 0.25 times 0.75 divided by 51, about 0.0606. And the statistic, what we're testing is at 0.15. All right. So we'll just do normal CDF, where our lower is negative infinity, our upper is 0.15, our mean is 0.25, and then you can put as many decimals as you want right there. And we get a value of about 0.050. So our correct answer here is A. So let me go ahead and put pen. Boom. I think I forgot to circle these. So that is our answer right there. Okay. Which of the following could also calculate the probability of less than 15% yellow? And so you can see these are all written as Z-scores. A lot of times on your AP exam, they're going to give you a Z-score and actually have a formula. So what you would do is you might see this piece right here. So it might actually show up like this in the answer choices. So that's a possibility right there, okay? But basically, the correct answer is C. So how do we do it? We just convert our value, our proportion, to its appropriate Z-score. So our statistic is 0.15, our true mean is 0.25, and then our standard deviation, which we calculated right there. So you can see that that is another way to show the probability of calculating less than 15% yellow. Okay, so be prepared to calculate Z-scores or to even choose among Z-scores, making sure they match. And so there you go. And we get same probability, which is 0.050. So that's a good sign. All right. Now, what is the probability? Now we've got two plants, and we're going to look at orange Reese's Pieces. It's 50% at plant A and 45% at plant B. She samples one bag of 51 pieces from each of the plants. What is the probability that the difference is greater than 10%? So we still need to check conditions. All right, here's everything I know. And we're going to have to assume that the samples are both random. It doesn't really say it, so say have to assume, and you're covered, okay? The 10% condition, 51 is definitely less than 10% of pieces at plant A and also at plant B, so we're fine there. Expected successes for plant A, we're fine. Failures at plant A, we're fine. Successes at plant B, looking good. And successes at failures at plant B. Remember, you have to show all of these calculations to get credit, all right? So when you're checking conditions, now if I tell you conditions are met, good news, you can skip this entire phase right here. And for time's sake, I frequently will say check conditions on a free response problem, but I might give you another free response problem where I'm like, assume conditions are met, and you can skip this piece. All right, so conditions are met. We can use a normal distribution. So now we get to do the calculations. This one's a little more intensive, but not too bad. So we calculate the actual difference in our parameters. So we find that we expect a difference of 0.05, right? So that's the difference in the two proportions. Then I substitute in the values with the calculator, and I get my new standard deviation. And so I have my true mean and I have my standard deviation, and I can just basically go do normal CDF, right? And I get a value of about 30.63% or 0.306. So the correct answer is B. All right, my mouse is a little slow today. That's why it's so weird. And that's it. Good luck on your quiz.